Question 7. Find the area of the triangle with coordinates of points A, 1, -1, 3, B, -2, -5, 4, and C, 3, 1, -4. So find the area of the triangle with these coordinates. So these are coordinates points. So we need to form vectors connecting these coordinates. And we just need two vectors. So we'll do AB and then we'll do AC. Then we'll be done with finding vectors, then we'll find the area. So AB is a vector. You start with the B coordinate and subtract the A coordinate. Start with the B coordinate, subtract the A coordinate. Start with the B coordinate, start the A coordinate. So this will give us -3, -4, and +1. Then we also get AC. AC, we start with the C coordinate, bring in the A, okay, so we have 2, 2, -7. So I have found two vectors, and we're assuming that we have a structure that looks like this one. But this is A, and this is C, and also this is A, and this is B. So we want to find the triangle that is made of these points, but now we're not looking at it as a triangle in the first place. We'll look at it as a parallelogram made of these two vectors. So this is what we are thinking of in mind. So we'll find the area of this structure. So the area of this structure is given by the cross product of AB cross AC. Because we have found a vector that goes like this and the vector that goes like this. So that this vector here has same direction with this one and this vector there. So they are same vectors. So when you get the area of this whole structure, when you say cross product, we define the cross product as a determinant of the matrix I, J, K, the matrix -3, -4, +1, the matrix 2, 2, -7, which is equal to I, and then you cancel here, cancel there, then you get 28 minus 2, -j, you cancel here, you cancel there, get 21 minus 2 plus k, you cancel here, you cancel there, get -6 plus 8. And then 28 minus 2, that is 26i, 21 minus 2, and plus 2k. So when you have this, then you find the magnitude of this vector, which is the square root of 26 squared plus negative 19 squared plus 2 squared, which is equal to 26 squared plus 19 squared plus 2 squared, giving us 1041. This area is for the parallelogram, but you're looking for the area of a triangle. So you say, hence, of combined to maintain. Hence, the area of the triangle ABC is equal to 1041 divided by 2. So this divided by 2, we get 520.5 units squared. So this is the area. So you got the area of the parallelogram and then get its half. Okay, so we go to
So
hello.
the 1041 was inside the square root. I think you forgot to square root that value.
Oh yeah. All right. Just inside the square, so we square root it. I thought we did that. The square root of 1041. Now it's 2 point something. So the square root of to the source, which is equal to 32.2645 3161. Then we divide by 2. Then we'll get the area. So we're seeing 32.2645. We divide by 2. Then we'll get 16.13 units squared. Okay. That's how we obtain this area. And this is question 7. So we go to question 8. Question 8, find the volume of the parallel pipe whose coterminous edges are given by the vectors 2i minus 3j plus 4k. Vectors I plus 2j minus k and 3i minus j plus 2k. And they're looking for the volume. So the edges are not the points, the edges are the sides. So it means that we already have the vectors that are surrounding the structure that we're dealing with. So to get the volume of it, the volume formula actually is just getting U dot so U dot V cross W. But then doing this is just the same as getting the determinant of all the three matrices vectors put together. So this determinant is just a determinant of 2. If I go by the first row, then you cut here, you cut there, then you have 4 minus 1, and then plus 3. You cut here, and you cut there, then you have 2 plus 3, and then plus 4. You cut here, and you cut there, then you have negative 1 minus 6. So get 2, 3, plus 3, 5, plus 4, negative 7, giving us 6 plus 15 minus 28. That is 6 minus 6 plus 15 minus 28, which is negative 7. And so to get the volume, you get the absolute value of this thing. Because you understand that it can actually be negative at some point. So the absolute value of this guy is negative 7 square root, which is 49, giving us 7 units cubed. That's how we get the volume. So the volume, the area of these structures in vectors is given by the determinant of the matrix. So the job is to find the determinant of the matrix. So that in question 9, you form, in question 9, it will be now you to form the, vectors, and then you use them to get, because what are given there are points. So you form the vectors and then use those vectors to form, to find the volume. So that we go to question 10, because question 9 is exactly the same as what you're from doing, except that you're moving from points to vectors and then you get the volume. Show that the 4 points, 6, negative 7, 0, that 16, negative 19, negative 4, that's 0, 3, negative 6, that's 2, negative 5, 10. Show that these points lie on the same plane. So to show that these points lie on the same plane, suppose we call the points A, B, C, D. You form vectors along these points. So start with vector A, that is 16 minus 6, negative 19 minus negative 7, and negative 4 minus 0, you form vector BC, that is 0 minus 16, 3 minus negative 19, and negative 6 minus negative 4. Then CD 2 minus 0, and negative 5 minus 3, and 10 minus negative 6. If we simplify them, we're saying vector AB is equal to 10, negative 12, negative 4. Vector BC is equal to negative 16, 22, and negative 2. Vector CD is equal to 2, negative 8, positive 16. Then you form the cross product of these vectors: 10, negative 12, negative 4, negative 16, 22, negative 2, 2, negative 8, 16, and get the determinant. So we have 10. If the determinant comes out to be 0, then these points lie on the same plane. So that will give us 22 multiplied by 16 minus 2 minus negative 2 by negative 8, which is positive 16. And then plus 12. So 12 becomes plus because where it is sitting there's an invisible negative. So 12. And then you cancel each column and each row. Then you remain with 16 by 16, negative 16 by 16, minus, which later becomes positive 4 because of the minus which is here. And then minus 4. You remove again, you get 16 by 8. I've left the negatives because there are 2. Minus 22 by 2, which is 44. Then now we do the computation. So we have 10, 22 by 16. That is 352 minus 16. You get 336. Plus 12. 16 by 16. Negative 256. Let's just get the whole figure. Negative 256 plus 4. That is the negative 252. And then minus 4. 16 by 8 minus 44. That's 84. Which is 3360. And then 252 by 12. You get minus 3024. Then 84 by 4. 84 by 4. You get negative 336. So we do the addition here. So 3360 minus 3024 minus 336. We get 0. When you get 0, then you conclude that hence the points are you calling them points or vectors? Hence the points lie on the same plane. If you find that this cross product does not give you a 0, then you say they do not lie on the same plane.
So why were you subtracting AB again? To find vector AB.
To find the vector, you subtract the points. Look, if you have a point here and the point there, and you want to find this vector here in this direction, then for you to get, if this is AB and this is CD, for you to form the vector AB in this direction, you go to B and get C and subtract A. You go to D and subtract B to form the vector shows us the direction and it has magnitude in that direction. Okay, question 11. Question 11. If A as a vector is negative 3i minus j plus 5k, B as a vector is I minus 2j plus k, C as a vector is 4j minus 5k. Find A dot B cross C. So you first could get the cross of this guy, or you just get the determinant of all the matrices placed together. So since we did this in question 8, so now we'll go this long way. So let's get B cross C and then come back to get the dot product with A. So B cross C is I, J, K, and then get B, 1, negative 2, 1, and then get C, 0, 4, negative 5. So because there's no I there, we put 0 for I. Then this is I, 10 minus 4, minus J, negative 5, minus 0. Oh, I think we do that. Plus K, 4 minus 0. So we get 5, we get 6 I plus 5j plus 4k. Then now we are doing the dot product. So we have negative 3, negative 1, positive 5, dot 6, 5, 4. This is equal to negative 18 minus 5 plus 20. This is 2 minus 5, which is negative 3. So it was just the dot product. So we leave the number as we found it. And then question 12 is exactly the same as question 9. We are given points, which are called position vectors. So you find the direction vectors in between those position vectors, and then use them to find the volume. We're calculating the determinant, whose the determinant of the matrix formed by all the vectors, by all the 3 vectors. And then question 13. Question 13 is for you guys, where you are doing the the screen must be visible now, everybody. On question 12, we are saying, since you are given points A, 5, negative 1, 1. You're also given B, negative 2, 3, 4. You're also given C, 3, 4, 5. Get vector AB, which is negative 7, positive 4, and 3. Get vector A, so that's AB, and then you get AC, since I have AB, wait then, but I have AB, then I'll get BC. So BC, that is 5, 1, 1. And then you get vector CA. So CA is 2, 2, and then negative 5, then negative 4. Then to get the volume, you get the determinant of negative 7, 4, 3, 5, 1, 1, 2, negative 5, negative 4, which is equal to negative 7, negative 4 plus 5, it's negative 3. And then minus 4, negative 20 minus 2, and then plus 3, negative 25 minus 2, negative 7, 1, minus 4, negative 22, plus 3, negative 27. So you calculate now. So you get -7 plus 4 by 22 plus -27 by 3. Just funny. So giving 0. So when you get 0, you can't even say anything. Just 0 and you're looking for a volume. So it is 0 units cubed. That's a measure of volume. So we log out and quickly come back so that we do matrices.